Hello all, welcome back to our deep learning series. In the previous episode, we understood how deep learning recognizes handwritten digits. Today, we are going to understand how to build a deep learning model using Keras. Until now, we discussed what happens inside a neural network. But now the question is, how do we actually create the neural network in a code? This is where TensorFlow and Keras become very useful. Think of Keras like a simple model building interface. Instead of writing everything from scratch, like matrix multiplication, weight initialization, layer connections, and training a structure, Keras gives us a clean and readable way to define the model. In this video, we will focus on four important ideas. First, what TensorFlow and Keras are. Second, how deep learning models are built in simple steps like define, compile, and train. Third, what a sequential model is and why it is useful for classification. Fourth, what common layers and activation functions are used in a basic neural network. So let us start building models with Keras. Before going into the code, let us understand the complete model building process in very simple way. In Keras, we usually build a deep learning model in three main steps. It is very brief intro to make things simple. Step 1. It is define the model. So this means we decide the architecture of the neural network. Architecture means the structure of the model. For example, how many layers do we need and how many neurons should each layer have, which activation function should we use, and what should be the input shape and output layer. For our MNIST example, the input is 28 by 28 image. If we flatten it, it becomes 784 values. So our input size is 784. Then we may add a dense layer. So let's say, for example, some neurons, 128 neurons, and after it we give it as a ReLU activation. And we may add a dropout to reduce the overfitting. We will discuss it in detail in the next slide. And finally, we add a dense layer with 10 neurons and softmax activation. Because we have 10 classes, so that's why 10 neurons are needed. So because it's a digit classification from 0 to 9. In Keras, this model definitions can be written using a simple line keras.sequential. And step number 2 is compile the model. After defining the model structure, we must tell the model how it should learn. This means we choose three important things like loss function, optimizer, and metrics. Loss function tells the model how wrong the prediction is, and optimizer tells the model how to update the weights. Metrics help us measure the performance, for example, accuracy. In Keras, we usually write this using a simple line model.compile. Step number 3, in training the model. Training means we show the model many examples, allow it to make predictions, calculate the error, and update the weights again and again. This is where the model actually learns from data. In Keras, training is done using a simple line model.fit. So the full journey is very simple. Define the model, compile the model, train the model. This is why Keras is beginner friendly. It allows us to focus on the concept first without getting lost in very low level implementation details. In this episode, we are mainly focusing on step number 1, defining the model. In the next episode, we will go deeper into compile and train, where we will discuss loss, optimizer, metrics, and model.fit in detail. Now let us understand TensorFlow and Keras. Many beginners get confused here. They ask, should I learn TensorFlow or Keras? Are they different? Are they same? Let us make it simple. TensorFlow is a deep learning and machine learning platform. It handles the heavy computation behind the scenes. It can run operations on CPU, GPU, or TPUs, like central processing unit, like this. TensorFlow is like the engine, where Keras is high-level API that helps us build models easily. It gives us simple functions and clean syntax for creating neural networks. Keras is like the easy control panel. TensorFlow is like engine. So a simple way to remember, Keras gives us a simple interface TensorFlow provides the computation engine behind the model. Now look at the first panel. We write Python code. Using that code, we create models with Keras. Keras works with TensorFlow to perform deep learning computation. Then TensorFlow runs those computations on CPU, GPU or TPU depending on your computer configuration. Now look at the second panel. Why do we use them? First, readability of the code. And Keras code is clean and understandable. So when we define layers, we can almost read the models like a sentence. Second, fast experimentation. In deep learning, we often try many models. We may change the number of neurons, add dropout layers, change activation functions, or adjust the architecture. Keras makes this experimentation faster. Third, it scales from laptop to cloud. You can begin with a small model on your laptop. Later, the same idea can be scaled to more powerful hardware. And fourth, research to production. The same tool can be used for learning, experiments, research, and real applications. Now look at the third panel where the TensorFlow and Keras used. They are used in computer vision, natural language process, speech recognition, and recommendation system as we discussed in the previous episodes. Now let us understand the sequential model. A sequential model is one of the simplest way to build a neural network in Keras. Sequential means one after the other. That means the data follow from the input layer to the first layer, then to the next layer, then to the next layer, and finally to the output layer. There is one input path and one output path. This is perfect for MNIST example because the flow is simple. Input image goes in hidden layers, process it, output layer gives the probabilities for the digit. Now look at the flow on the slide. First we have the input. Our MNIST image is 28 by 28 pixel, so it is 784 if you multiply it. So the input is represented by 784 numbers. Next, the digits go to the dense layer. So here I consider 120 neurons in the architecture with a combination of ReLU activation. Dense means fully connected. Every input value is connected to every neuron in that layer. This layer tries to learn useful patterns from the input pixels. For example, some neurons may become sensitive to strokes, curves, edges, or digit-like patterns. After that, we use dropout with a value of 0.2. Dropout means during the training, some neurons are randomly switched off. Here 0.2 means 20% of the units may be dropped out during the training. Why do we do this? To reduce the overfitting. Overfitting means the model memorizes the training data too much and does not generalize well to the new data. So dropout forces the model to learn more robust patterns. So that means if the overfitting is more, your data is fully adaptable for this particular case. If you give it to the new data, there is high chance and risk to predict it wrongly. So that's why we are avoiding the overfitting by introducing the dropout layers. Then we add another dense layer with 10 neurons and softmax activation. Why 10 neurons? Because MNIST has 10 classes from 0 to 9. So each output neuron represents one digit class. And softmax converts the outputs into the probabilities. For example, the model may say digit 0 is 0.01, digit 1 is 0.02, digit 2 is 0.03, and digit 8 is 0.93. Now the digit with the highest probability becomes the prediction. So if the digit 8 has the highest probability, then the model predict it as 8. Now let us look at the Keras code. Model equals keras.sequential. Inside that we add layers one by one. Okay, we can say output first. That means 128 is the first we have to write, which is an output. Okay, and we write the activation function, which is ReLU, then input shape 784. So the pattern is output comma activation function comma input shape. And second layer we are introduced dropout. So write dropout is 0.2. Third layer dense 10 and activation is softmax as we discussed. This is a simple multi-layer perceptron, or we can call it a simply MLP. A single perceptron is limited, like as we discussed earlier. But when we stack several dense layers, we create a MLP. So MLP is nothing but just add multiple layers in between input and output. If you add the multiple layers, then we are calling it as a multi-layer perceptron. So that can learn more complex patterns. Now let us understand activation function. This is one of the most important idea in neural networks. In the previous episodes, we discussed the neuron computation, like z equals to summation of wi xi plus p. That means the neuron takes input, multiply them by weights and add them together, add bias to it. This gives us the weighted sum z. But after that, we apply an activation function. So the output becomes y equals to f of z. The activation function decides how the neuron should respond to the weighted sum. Now the big question is, why do we need activation functions? The answer is non-linearity. The activation functions introduced non-linearity into the neural networks. Without activation functions, even if we stack many layers, the whole network would behave like a one linear model, because we are using an equation called y is equal to mx plus c kind of thing. That means it would not be able to learn complex patterns. But handwritten digits are not simple straight line patterns. The shapes, if you look 8, 3, 5 or 9, contains curves, loops, strokes and variations. So we need non-linearity to learn the complex patterns. Let us understand the common activation functions. First, ReLU. ReLU stands for rectified linear unit. The equation is ReLU of x equals to maximum of x comma 0 comma x. That means if x is negative, output is 0. If x is positive, output is x itself. So whenever we have negative values, it will become 0. So ReLU is simple and fast. It is commonly used in hidden layers because it helps neural network learn effectively and supports better gradient flow compared with older activations like sigmoid in many deep learning networks. For MNIST, ReLU is commonly used in hidden layers. Second activation function is sigmoid. The sigmoid function outputs values between 0 and 1. Its equation is 1 divided by 1 plus e power minus x. Sigmoid is useful when we want a binary probability, for example yes or no, spam or not spam, dog or not dog. But for hidden layers in deep networks, sigmoid can sometimes cause gradient to become very small. So especially when the values are saturated near to 0 or 1, it becomes very small and it won't give you much better results. The third activation function is tanh. Tanh output values between -1 and +1. It is a zero centered, so measure output can be negative, 0 or positive. This can be useful in some neural network designs. Fourth one is softmax. Softmax is used in the final layer for multi-class classification. For MNIST, we have 10 classes. So softmax gives 10 probability values, one probability for each digit. The important point is each output is between 0 and 1. All outputs sum to 1. For example, digit 1, digit 0, digit 8, probabilities if you add it up, you will get the value as 1. If digit 8 has the highest probability, then the model predicts it as 8. So for our MNIST model, ReLU is used in the hidden layer, softmax is used in the final output layer. Now it's a quiz time. Pause the video and write your answers in the comment section. Question number 1. Why is ReLU commonly preferred in the hidden layers of simple MNIST classifier? Option A. It introduces nonlinearity and helps efficient gradient flow. Option B. It forces all outputs to sum to 1. Option C. It is randomly removes neurons during training. Option D. It converts image into a 1D vector. Question number 2. Why is the sequential model a good fit for basic MNIST MLP? MNIST requires option A. MNIST requires multiple input branches. Option B. The data flows through a single ordered pipeline from input to output. Option C. Sequential models automatically choose the optimizer. Option D. Sequential replaces TensorFlow during training. Let us know the answers. If you write in the comment section, good. So let's check it out. Question number 1, correct answer is A. And question number 2 correct answer is B. That's all for this episode. If this video helped you, please like, comment, share and subscribe. Thank you for watching till here. Have a good day.